So we've done the two types of hadrons. Now another type of particle you know about leptons, and leptons are defined as fundamental particles and antiparticles which do not interact through the strong nuclear interaction. Okay, the fundamental here means that they're not made out of smaller particles. Unlike the hadrons, which are made out of quarks, leptons cannot be broken down to smaller parts. And there's three types of leptons you know about, which is the electrons, muons, and the following corresponding neutrinos. Okay, let's look at the different types of leptons. Firstly, we've got the electron, which you're familiar with, -1 charge, and because it's a particle and it's a lepton as well, we give it a lepton number of +1. Okay, the next one is the electron neutrino. The electron neutrino is a very small mass particle, even smaller mass than that of an electron, and it's very weakly interacting. So there's thousands of neutrinos going through you right now from the sun, and it doesn't interact with things. It rarely interacts with things. Okay, also it's got a 0 charge, which means that it doesn't interact through the electromagnetic force either. Okay, and because it is a particle and it is a lepton, again, it's got a lepton number of +1. The next one here is the positron, which is the antiparticle of the electron, so +1 charge, and because it's an antiparticle, it's got a -1 electron lepton number. Okay, here we have the electron anti-neutrino. Okay, so a lot of people incorrectly say it's the anti-electron neutrino. Okay, this is not how you say it. It's the electron anti-neutrino. Okay, and it's got a 0 charge, just like the neutrino, and because it's an antiparticle, it's got a -1 lepton number. Okay, all the other baryon number, strangeness, and this other lepton number, mu1 lepton number, which will come on to later, all these are 0. Okay, it's not a baryon. It's not made out of quark, so it's got no strangeness because it can't be made out of a strange quark, and it's not a mu1, so it's got a mu number of 0. Another type of leptons we need to know about are called muons. They're given this Greek letter as a symbol, mu, and they're basically just heavier versions of the electron, okay, around 200 times more mass, which also means that they have very short half-life and they decay into other particles. For example, they decay into electrons. Okay, and they have the same charge as an electron, but they don't have electron lepton numbers. They have muon lepton numbers. Their electron lepton numbers of a muon is 0. Okay, and they come with a corresponding neutrino as well. So this is a muon neutrino, again 0 charge, and because it's a particle and a lepton at the same time, it's got a +1 of muon lepton number. And then the corresponding antiparticles, which is the anti-muon. Okay, so it's got a positive charge and mu1 lepton number of -1, and then here got to be careful pronouncing, this is the muon anti-neutrino, not the anti-muon neutrino. That is not how you name this particle. Okay, and again these have a charge of 0 and -1 electron and mu1 lepton number. The baryon number, strangeness, and electron lepton number for all these are 0, as we'd expect.